Dear students, in last class we have studied the properties of insulators. In today's class we shall discuss the breakdown phenomena in gaseous insulators. First we shall define what is dielectric strength of an insulator. It is the maximum voltage that an insulator can withstand without entering into the state of conduction. It is measured in kilovolt per centimeter. Gaseous insulators most of the electrical apparatus use air as an insulator. And in few cases other gases such as nitrogen, that is N2, carbon dioxide, that is CO2, freon, that is CCl2F2, gases break down only when ionization of the gases takes place, and sulfur, hexafluoride, that is SF6, are also used. Ionization processes in gases. A gas in its normal state is almost a perfect insulator. However, when a high voltage is applied between the two electrodes in a gaseous medium as shown here. Here is a enclosure, a box like structure it is, in which the two electrodes are immersed in a gas. When voltage is not applied here, the gas is perfect insulator. If I go on increasing the applied voltage, in that case, the gas between the two electrodes here becomes a conductor at certain applied voltage, and the electrical breakdown of the gas occurs, which means that the current starts to flow between the two electrodes. In the arrangement, shown in figure above, gas is perfect insulator in its normal state. When applied voltage is gradually increased, the gas becomes a conductor and an electrical breakdown occurs at a voltage higher than the breakdown strength of the gas. The processes that are primarily responsible for the breakdown of a gas are ionization by collision, photo-ionization, and the secondary ionization. process. In insulating gases, the process of attachment also plays an important role. So to understand electrical breakdown of the gases, we need to understand what is ionization by collision, photo-ionization, the secondary ionization, also the process of attachment. Now let us learn these processes one by one. First one is ionization by collision. Whenever a gas atom or a molecule is hit by an electron, due to the impact of collision, electron will be dislodged from the atom or molecule of gas. Hence, an positive ion and an electron will be formed. So this is gas atom or molecule. Now the gas atom or molecule, after losing an electron, has become an ion, and that is a positive ion. So here collision is taking place. Out of these two electrons, one electron is a free electron and another one is an electron dislodged from the gas atom or molecule. This is ion of gas. So we'll first write the definition of ionization by collision process. The process of liberating an electron from a gas molecule with the simultaneous production of Positive ion is called ionization. If we consider a low pressure gas column in which an electric field E is applied between E is applied across two plane parallel electrodes. As shown in figure. Below. Then any electron starting at the cathode will be accelerated more and more between collisions with other gas molecules during its travel towards the anode. Here you can see the two electrodes. Now the two electrodes are connected to the adjustable HV source terminals through an ammeter and a current limiting resistor. Current limiting resistor here is essential because if the gas medium between two electrodes breaks down electrically, a heavy current will be flowing through the circuit and the HV source will be heavily loaded. In order to prevent that heavy loading of adjustable HV source, a current limiting resistor R is connected. Electrode connected to negative terminal of HV source is cathode, and the electrode connected to positive terminal of HV source is anode. Since voltage is applied to these two electrodes here, there exists an electric field between the two electrodes, and the direction of electric field is from cathode to anode, which you can see between the electrodes. Now there will be gas molecules in between the two electrodes here. These gas molecules here are at low pressure. At certain HV voltage, the cathode will emit an electron, and this electron will collide with the gas atom or molecule, and then it will change its direction. Again it will collide with another gas molecule or atom, and so on, and finally it will reach anode. In between the gas molecules here, or gas atoms, when electron moves, it will be accelerated. That means its velocity will be increasing. It is so because there exists an electric field between the electrodes, and that electric field will be accelerating this electron. And when this electron accelerates, its velocity increases, it will gain energy. We know that moving object possesses energy called kinetic energy, and that kinetic energy is given by half into m into v square, where m is the mass of moving object and v is the velocity of moving object. Since kinetic energy is equal to half mv square, here in this case m is mass of electron and v is the velocity of electron. Kinetic energy is proportional to square of the velocity. As the velocity of electron increases, kinetic energy of that electron will increase as the square of the velocity. So if the kinetic energy gained by electron exceeds the ionization energy of gas molecule with which it collides, then that particular gas molecule or atom will give out an electron, and that gas molecule or atom will become positive ion. If the energy denoted by epsilon gained during the travel between collisions exceeds the ionization potential Vi, which is the energy required dislodge an electron from its atomic shell. We all know that electrons which revolve in the shells of an atom are being held in their positions by the attractive force of protons that are there in the nucleus. So to overcome that force of attraction, a sufficient energy is to be applied to the electrons that are there in outermost shell, and that sufficient energy is called ionization potential. So during a collision, what happens is a free electron which has gained sufficient energy, that is epsilon more than Vi, when hits an atom, that atom will give out an electron. Then ionization takes place, and this entire process can be represented as electron colliding with an atom or molecule of gas and electron having energy more than ionization potential Vi will dislodge an electron from the gas molecule or atom, thereby converting the gas atom or molecule into a positive ion. Where A is the atom, A plus is the positive ion, and E minus is the electron. The cathode here may also emit some of the electrons due to ultraviolet light falling on it. The electron given out by the cathode in this case also will be moving towards the anode, and when it starts moving towards the anode it will keep colliding with the gas molecules, and during its travel between the collisions, if the energy gained is more than ionization energy of the gas atom or molecule, then the gas molecule will give out an electron and it will become, that is, the gas atom will become a positive ion. So cathode may emit electron due to the applied high voltage or due to ultraviolet light falling on it, or due to both. A few of the electrons produced at the cathode by some external means, say ultraviolet light, falling on the cathode as shown in figure above. Ionize neutral gas atoms or molecules, producing positive ions and additional electrons. The positive ions on reaching and bombarding with cathode give rise to secondary electrons. Remember, in a collision, bombarding electrons are primary electrons and electrons dislodged from gas atom or molecule are secondary electrons. Next, we will learn photo-ionization. In case of photo-ionization, A gas atom or molecule gets ionized due to its interaction with the radiation. During the interaction of radiation with gas atom or molecule, what happens is the atom or molecule absorbs the energy from radiations. If that absorbed energy from the radiation is more than the ionization potential, then the ionization takes place. The phenomenon associated with ionization by radiation or photo-ionization involves the interaction of radiation with matter. Here matter means gas. Photo-ionization occurs when the amount of radiation energy absorbed by an atom or molecule is more than ionization potential. This process can be represented as H nu plus A equals A plus E minus, where H is the Planck's constant and nu is frequency of radiation. For ionization to take place, wavelength lambda should be less than or equal to C into h by Vi, where C is the speed of light. Where lambda is wavelength and C is the speed of light. Substituting for H and C, we get lambda less than or equal to 1.27 by Vi into 10 to the power minus 6 centimeter. So from this relationship we understand that if ionization energy is very high, then the wavelength of the radiation will be very short. Which means for higher ionization energy Vi, shorter wavelength radiations are required. For ionization to take place. It was observed experimentally that a radiation having a wavelength of 1250 angstrom is capable of causing photoionization of almost all gases. Dear students, with this we have completed ionization by collision and photoionization. In next class, we will continue with secondary ionization processes. Thank you.